EBaM, an EDA tool for battery modeling and electronic design, usually more focuses on energy efficiency of a device than on its energy source. Various battery modeling are proposed in literature. The most common ones are in the form of an equivalent electrical circuit. But generally, parameters of these models are generated and populated through empirical approaches and, therefore, laboratory measurements. A cheaper solution for battery modeling is to analyze their behavior but directly from information reported in their datasheets. Of course, this kind of modeling requires variable accuracy. In fact, model population depends on the available characteristics given by manufacturers, which usually differ from one to another. Our proposed framework for EBaM tool is based on 3 levels of modeling. Level 1 only models the battery runtime after considering the state of charge of the battery. This is an analytical model based on the well-known Pickert's law, which gives a relationship between the capacity of a battery and the battery runtime for a single cycle at a certain constant discharge current. The coefficient K is called the Pickert number. The level 2 model is based on an equivalent electrical circuit for a steady-state analysis of the battery discharge at constant current rates. The battery capacity is modeled through a capacitor, while a resistance models the total internal resistance as it is extracted from the voltage versus capacity characteristics after considering different constant discharge current rates. The temperature effects can be also modeled when more detailed information are provided in the datasheet. This effect is then modeled by a voltage source, that is V-drift. Level 3 is the highest level of modeling as it describes the transient response of a battery other than all the other characteristics already previously described. In this case, the modeling is still based on the equivalent electrical circuit. 2 RC groups model the long and short time effects, respectively, of the transient response. These models have been integrated into a tool, EBaM, for the estimation of a battery performance after considering the characteristics provided by the manufacturer. Evaluation of the proposed methodology for battery modeling was performed for 2 different lithium-ion cells. Panasonic CGR18650CG and Energizer CR2032. The characteristics of the Panasonic cell have been modeled at level 2, whereas the ones of the Energizer coin cell have been modeled at level 3. Firstly, we estimate the performance of the Panasonic cell at a constant discharge current, that is 2.15 ampere. The tool allows to set the current in ampere or in C rate, which is a normalized value of the current with respect to the nominal capacity of the battery. In this case, 2.15 ampere is equivalent to 1 C. For the level 2, there is no need to set the internal resistance of the battery through a file or a constant value. In fact, in this case, the internal resistance is extracted directly from the characteristics provided in the datasheet. The estimation, the blue curve, shows a very good accuracy of the proposed models with respect to the original manufacturer's data. For the level 3, we select the coin cell CR2032 by Energizer, and for this model level, we must set the internal resistance. In this case, we set the file name of the data array, which reports in a numerical form the characteristics internal resistance versus state of charge of the battery under test. Then we estimate the performance of the cell for a pulse at 24 milliamps. As we can see, also in this case the performance estimation is very close to the manufacturer's data. So, at the end, a designer can fully simulate a battery-powered system after including also the battery performance through EBaM, the novel tool for battery modeling. Thank you very much.